Hi friends, I am Vishwanath studying Computer Science Engineering in Amrita Vishwa Vidyapita. In this video, I am going to say about the insertion in an AVL tree. First, let us see what is an AVL tree. An AVL tree is a self-balancing binary search tree. In an AVL tree, the heights of the two child subtrees of any node differ by at most one. If at any time they differ by more than one, rebalancing is done to restore this property. Yeah. Now we'll see the code for the insertion in an AVL tree. First we'll define AVL node, which will give us an idea how every node in our tree looks like. That means what are all the features in our node are going to have. By this method, we are going to define our node. So our node is going to have a data part, left and right child, and also a balance factor. Here this method is going to initialize the node in our tree, and this is the pictorial representation of a node in the AVL tree. Then in the driver class, we are creating an object O1 of type AVL tree. AVL tree class contains root of AVL node type and also insert method in it, which will help us in insertion of nodes into the tree. In this method, we are checking whether the tree is empty or not. If it is empty, we are directly adding the node to the tree, or else we are going to call another insert method of type AVL node, which will be invoked by the objects. Here comes the insertion method, which is invoked using objects. In this, we are checking the key with the data, that means the root data, which is invoked, of the node which is invoked this method. If key is less than data, then it will enter first if loop. And in the first if loop, if the left side is empty, then we will directly create a node and insert it over there. If it is not, the iterative process keeps on going and keep going. And if the key is greater, then it will enter the else part. The same process keeps going on till the insertion happens. After the every insertion, we will be checking the balance factor, and then the important part comes, that is balance factor. Here balance factor, we are going to call compute balance, which will return the balance factor. Now if the balance factor is 2, then it is not balanced on the left side, so we will rotate it with left side. Else if it is -2, then it is not balanced on the right side, so we will rotate with right side. And then at last we will return the root part which invoked this method or class. Now I will explain the insertion with one example. Let us consider an empty AVL tree, and the question is insert 20, 15, 25, 10, 5 into an AVL tree. Now the present AVL tree is empty, so it will be null everywhere. First, insertion of 20. As tree is empty, we can directly insert 20 into the tree. Next, insertion of 15. Now tree is not an empty, then we have to check for the condition, and as 15 is less than 20, we have to insert on the left side of the 20. Same as such, insertion of 25, 10 and 5 takes place. But after 5, after insertion of 5, we will be seeing the violation of property. Now, as this is balance factor is 2, it is having an violation on the left side. Now we'll be rotating it with the left child, and this is our answer. Thank you for watching my video.